this week. Now, as you can see on the screen, we have this distribution here. You can call it gamma. We have this distribution. You can call it binomial. We can lead to exponential. We have a chi-square, and we have this one. So we'll be looking at the relationship between all this distribution. Now, first of all, we start with a binomial and Bernoulli distribution. So I want to see the relationship between binomial and Bernoulli distribution. As we already know that a binomial, which is an n, p random variable with n equals 1, is a Bernoulli random variable. So if I have a binomial distribution with this n, p as parameter, random variable, with n equals to 1, we can see in binomial distribution n run from 0 to positive infinity. Now, in a case where we now have it as n equals to 1, then this binomial distribution will become Bernoulli distribution with parameter p. Now, let's look at this. A binomial distribution is given as, now I want to see the probability density function of a binomial distribution. Then we have a p of x equals to summation x run from 0 to n combination x, then p raised to power x, q raised to power n minus x, where p and q are the parameters. P and q are the parameters. Now this p is the probability of success, while we have this q as the probability of failure. So in this function, in this density function, we have a p to be the probability of success and q to be the probability of failure. Now, in a case whereby this n is now run from 0 to n, that is, the variable run from 0 to n, and our n equals to this one, then binomial distribution would definitely become Bernoulli distribution. Now we say binomial distribution becomes Bernoulli distribution in what case? When n equals 1. When n equals 1, then this binomial distribution will definitely become Bernoulli distribution. Then we have a p of x equals to summation x run from 0 to 1, p raised to power s, q raised to power 1 minus x, which is a Bernoulli distribution. We can see from binomial distribution back to Bernoulli distribution when our n is equals to 1. So binomial distribution definitely become Bernoulli. We can see that. Now the next one we are going to look at gamma and exponential. Now we look at gamma and exponential. The relationship between gamma and exponential. How are they related? What is the relationship between the two? Now we see they say a gamma distribution we shape parameter alpha equals to 1. We shape parameter alpha equals 1, and the scale parameter beta is an exponential beta into bracket distribution. So a gamma distribution we shapes parameter when our alpha equals 1, then we'll say that gamma distribution is an exponential distribution. Now the density function of gamma is given as, now I want to state the probability density function of gamma distribution. So what is the distribution? We have it as f of x equals to lambda raised to power alpha x raised to power alpha minus 1 exponential raised to power minus lambda x divided by alpha. Then our x is greater than 0 less than infinity, which means x span from 0 to infinity. Now this density function of gamma can definitely become an exponential distribution if our alpha is equals to 1. If our alpha is set to 1, this gamma distribution here will definitely become an exponential distribution. That is, this alpha here become 1, then we have 1 minus 1. This is going to be eliminated because everything here is going to be 1, and at the denominator side this is going to be 1, and everything raised to power divided by 1 will still give us that function. Now we have here lambda raised to power alpha will definitely become ordinary lambda. Now let's see. This becomes exponential distribution when alpha equals 1. So what do you mean by this? So that is, this is what we mean by this now. Saying f of x equals to lambda raised to power 1, x raised to power 1 minus 1, exponential minus lambda x divided by 1, or x still run from 0 to positive infinity. We can see now that this our alpha here has become 1 here, alpha here has become 1 here. So as a result, now we have 1 minus 1 here. This is 0. X raised to power 0 will definitely give us 1. So this is gone already. Now we have a lambda raised to power 1, which will definitely become lambda. And this denominator here will also become 1. And as you know, any value divided by 1 will still give us that value. So therefore, this distribution here will now become p of x equals to lambda exponential raised to power minus lambda x. We say have x is greater than 0, less than infinity. That becomes exponential distribution. We can see this gamma distribution definitely become exponential distribution when we set alpha to be equals 1, and when we set alpha to be equals 1, definitely we can see what happened here. This gamma distribution willingly become an exponential distribution. We can see lambda exponential raised to power minus lambda x. So next we are going to look at now, we look at gamma and chi-square distribution. Yeah, we look at gamma and chi-square distribution. What is the relationship between this gamma and the chi-square distribution? Are they related? Can gamma distribution definitely become chi-square distribution, or can chi-square distribution becomes gamma distribution? Now let's look at this. Say a gamma alpha comma beta random variable with alpha equals to v over 2 and beta equals to 2 is a chi-square random variable with v degree of freedom. Yeah, with v degree of freedom. That is, when we set alpha to be equals to v over 2, where this our v stand for degree of freedom, now we have beta to be equals to. In gamma distribution, we have two parameters. The first parameter is this alpha, and the second parameter is beta. Now, in a case whereby alpha is now said to be v over 2, that is half of the degree of freedom, and we have a beta to be equals to, definitely this gamma distribution will become chi-square distribution. Now, so the probability density function of gamma distribution is given us. We want to state the probability density function of gamma. We said f of x equals 1 divided by beta raised to power alpha sine alpha x raised to power alpha minus 1 exponential raised to power minus x divided by beta. Now the probability density function is given as this. Now we have this interval, x is greater than 0, less than infinity, and we have the distribution here, the probability density function of gamma distribution. Now here we say, you can see exponential is raised to power x minus beta. Here we have one of the parameter, which is beta. Here we have one of the parameter here, which is alpha, and at the denominator both the parameters are there. Beta is raised to power alpha. And don't forget, when we set this alpha to be half of degree of freedom, v is the degree of freedom, and beta to be equals to 2, definitely it will become a chi-square distribution. Now let's see. So this distribution becomes chi-square distribution when alpha equals to v over 2 and beta equals to 2. Now it's going to give us a chi-square distribution. Now let's see what we're talking about. F of x now equals to 1 divided by 2 raised to power v over 2 sine into v over 2 bracket close, x raised to power v over 2 minus 1 exponential raised to power minus x over 2. So we still have our limit, x is greater than 0, less than infinity. This becomes chi-square distribution. So what has changed here? You can see this is alpha here. This alpha here becomes v over 2. Now beta's taking this value of 2. Now we have minus x divided by 2 instead of minus x divided by beta. And if you come at the denominator side, we have a beta raised to power alpha, and that becomes 2 raised to power v over 2. As stated here, that alpha becomes v over 2 and beta equals 2. Now alpha here becomes v divided by 2. Now this function that we have here is a chi-square distribution. So which means we have a probability density function of chi-square distribution is what we have here, which means gamma distribution can become a chi-square distribution as far as alpha is said to be half of freedom, degree of freedom, and we have the beta to be equals to 2. Definitely we are going to have a chi-square distribution. Now we're now going to compare 3, which is a chi-square and exponential distribution. Now I want to compare chi-square and exponential distribution. How are they related? Can chi-square distribution become an exponential distribution? So that's what we're going to look at now. So we're saying a chi-square distribution with degree of freedom 2 is an exponential distribution with mean 2 and vice versa. So what we're saying here is, once we set our degree of freedom to be equals 2, once our degree of freedom v is equals 2, then definitely this chi-square distribution will become an exponential distribution, and vice versa, which means exponential distribution too can become chi-square distribution. Now, first of all, we're saying the density function of chi-square distribution is given us. We want to state the probability density function of a chi-square distribution. So we say it is given us, say f of x equals to 1 divided by 2 raised to power v over 2 sin v divided by 2 bracket close x raised to power v over 2 minus 1 exponential raised to power minus x over 2. We have x greater than 0, less than infinity. You can see this is a chi-square distribution. And what we stated up here is when our degree of freedom v is said to be 2, and what is going to happen? What I mean is that this v here becomes 2, then we have 2 over 2, that is 1 minus 1. So automatically the whole of this will become 1. Then at the denominator side, we have 2 over 2 become 1. The whole of this here become 1. And finally, we're going to have 2 here. And you should not forget that the degree of freedom is said to be 2. Now, what happens? Saying chi-square becomes exponential with degree of freedom 2. With degree of freedom 2. When the degree of freedom is 2, then the chi-square distribution will become an exponential distribution. Now let's see what happened after that. So p of x equals to 1 divided by 2 raised to power 2 over 2 sign into bracket 2 divided by 2 bracket close x raised to power 2 over 2 minus 1 exponential raised to power minus x divided by 2. We still have our interval x greater than 0, less than positive infinity. Now, if you look at these two now, what has changed? Our v now has become 2. We can see that v here becomes 2. Then we have the power here, v here has also becomes 2. Now, by simple arithmetic, we can see that this is automatically 1 minus 1, and here we're going to have 1, and here we're going to have 1. Now let's see what we're talking about. So we have p of x equals to 1 divided by 2 raised to the power 1. I'll sign into brackets 1 x raised to the power 1 minus 1 exponential raised to the power minus x over 2 minus x over 2, and this become p of x equals to 1 divided by 2 raised to the power 2 over 2 x raised to the power 0 exponential raised to the power minus x over 2. You can see that here we already have x to be raised to the power of 0, which means definitely this x raised to the power 0 will go. And this 2 raised to the power 2 over 2 here is still the same thing as 2 raised to the power 1 that we have here. Now that we have the sign into 1, it becomes 1, and anything divided by 1 will still definitely give us 1. And as such, from this point now, you can see from this point now, here we're going to have a denominator of 2, because 2 divided by 2 will give us 1. So we're going to have a denominator of 2. X is going to leave this place because x raised to the power 0 will definitely give us 1. So we are dealing with exponential raised to the power minus x over 2 divided by these 2. Now let's see what we're talking about. So p of x equals to exponential raised to the power minus x over 2 divided by 2. Now you can see we already have this here now. So finally, what do? We have to make sure that our alpha is equals to 1 over beta. If we make our alpha to be equals to 1 over beta, you can see, and this 1 over beta we make it to be 1 over 2, because we've already stated it that when this becomes 2, now we have 1 over 2 here. So if we put this into what we have here, for example, now if you have alpha equals to 1 over beta and 1 over beta equals to 1 over 2, definitely what we're saying is that lambda is equals to 1 over 2, equals to 1 over 2. So that's what we're saying there. So instead of having 1 over 2 here now, 1 over 2 becomes lambda. And if 1 over 2 becomes lambda, definitely here we're going to have lambda here. And at this power here, we're still going to have another lambda. What have we said here? Now let's put it down. Say, when alpha equals to 1 over beta, and this 1 over beta equals to 1 over 2, therefore, p of x will become as the probability mass function will now becomes same p of x equals to lambda exponential raised to the power minus lambda x. We still have our interval x is greater than 0, less than infinity. Now what we're saying here is this is alpha, this is lambda, which is equivalent to 1 over beta. In some exponential distribution, instead of we use this, or we take this. Now since we have 1 over beta here equals to 1 over 2, which means automatically beta is equals to 2. Now if we remove this from the setting, we're going to have a lambda equals to 1 over 2. That is, this lambda equals to 1 over 2. And if lambda is equals to 1 over 2, apparently at this point here, we have 1 over 2 here. That has becomes this our lambda. Now at this numerator, we have minus 1 over 2 times x. That is what we have here. So that's 1 over 2 here has become another lambda. So that is why we have a minus lambda raised to the power x here. Now we've changed a chi-square distribution to exponential distribution when we set our degree of freedom to be 2. So I will stop here. These are the relationship between some probability distribution. We've mentioned chi-square and exponential, gamma and chi-square distribution, gamma and exponential distribution, binomial and Bernoulli distribution. We'll continue from here some other time. So please do not forget